The concept of aerodynamics, first discovered by Sir George Cayley in 1799, is crucial in building a kite that can soar to new heights. The Beaufort scale, developed by Sir Francis Beaufort in 1805, is used to measure wind speed, which is essential in determining the ideal conditions for kite flying. The Wright brothers, Orville and Wilbur, used a similar approach to data analysis to develop the first powered, heavier-than-air aircraft, demonstrating the importance of rigorous testing and data-driven design. The concept of lift, first described by Daniel Bernoulli in 1738, is crucial in understanding how kites can fly. The kite's tail helps to stabilize its flight, much like the way a meteorologist uses a wind vane to measure wind direction. The use of lightweight materials, such as silk or nylon, allows kites to fly higher and more efficiently, as demonstrated by the experiments of Octave Chanute in the late 19th century. The balance between lift and drag determines a kite's ability to fly steadily and soar to great heights, as explained by the principles of aerodynamics developed by scientists such as Ludwig Prandtl. In 1749, Benjamin Franklin's famous kite experiment demonstrated the connection between lightning and electricity, showcasing the power of wind in scientific discovery. The study of aerodynamics, led by pioneers like Octave Chanute, has revealed that even small changes in wind speed can significantly impact the flight of objects like kites. The concept of drag, first explored by scientist Ludwig Prandtl, plays a crucial role in understanding how kites interact with the wind and how their design can be optimized for better performance. Research by meteorologists, such as the work of Wilhelm Bjerknes, has shown that wind patterns can be influenced by a variety of factors, including temperature, humidity, and air pressure, all of which can impact the flight of a kite. In 1902, the Wright brothers conducted a series of experiments with gliders, which ultimately led to the development of the first powered heavier-than-air aircraft, demonstrating the importance of rigorous testing and data-driven design in aerodynamics. The concept of lift, first described by Daniel Bernoulli in 1738, is crucial in understanding how kites can fly, as it explains how the shape of the kite's surface deflects air downward, creating an upward force called lift. Octave Chanute's experiments with wing designs and gliders in the late 19th century laid the foundation for modern aerodynamics, and his work inspired many pioneers in the field, including the Wright brothers. The Beaufort scale, developed by Sir Francis Beaufort in 1805, is a widely used system for measuring wind speed, which is essential in determining the ideal conditions for kite flying, as it helps to predict the behavior of the kite in different wind conditions. In 1878, British engineer William Dines developed the first practical anemometer, paving the way for modern wind measurement techniques. The anemometer's ability to measure wind speed and direction has been crucial in understanding weather patterns, as demonstrated by the work of meteorologist Wilhelm Bjerknes. The measurement of wind speed and direction has numerous applications, including predicting weather patterns and optimizing wind turbine performance, as shown in the studies of the National Oceanic and Atmospheric Administration. In 1969, NASA's Apollo 11 mission successfully landed on the Moon, demonstrating the power of applying scientific knowledge to real-world problems, such as understanding wind resistance and aerodynamics. The work of engineer Octave Chanute, who published a comprehensive book on aviation in 1894, has inspired many inventors and engineers, including Sparks, to experiment with aerodynamic designs and wind-resistant materials. The concept of wind resistance, first studied by scientist Ludwig Prandtl in the early 20th century, is crucial in understanding how kites can fly steadily and efficiently, and how their design can be optimized for better performance. According to the National Oceanic and Atmospheric Administration, the study of wind patterns and aerodynamics has numerous applications, including predicting weather patterns, optimizing wind turbine performance, and improving aviation safety. In 1878, British engineer William Dines developed the first practical anemometer, paving the way for modern wind measurement techniques, which Sparks is now utilizing. According to the National Oceanic and Atmospheric Administration, the study of wind patterns and aerodynamics has numerous applications, including predicting weather patterns and optimizing wind turbine performance. The measurement of wind speed and direction has numerous applications, including predicting weather patterns and optimizing wind turbine performance, as shown in the studies of the National Oceanic and Atmospheric Administration. In 1960, the National Aeronautics and Space Administration launched the first successful weather satellite, TIROS-1, which paved the way for modern weather forecasting and the study of aerodynamics. The anemometer's design is based on the principle of rotational motion, where the cups rotate in response to wind speed, allowing for accurate measurements of wind velocity. According to the research of engineer Octave Chanute, the use of lightweight materials and optimized wing designs can significantly improve the performance of flying machines, such as kites and gliders. In 1878, British engineer William Dines developed the first practical anemometer, which paved the way for modern wind measurement techniques and our understanding of aerodynamics. The concept of aerodynamic efficiency, studied by pioneers like Octave Chanute, has led to significant advancements in wing design and flight technology. Research by scientists, like Daniel Bernoulli, has shown that the shape and curvature of a wing can significantly impact its ability to generate lift and thrust. The study of aerodynamics has led to numerous breakthroughs in fields like aviation and engineering, with pioneers like the Wright brothers pushing the boundaries of what is possible. The principle of lift, first described by Daniel Bernoulli, is a fundamental concept in aerodynamics and has been applied in numerous fields, from aviation to wind energy.